In this question, we will use integration by parts formula to compute integrals. Here we are being asked to integrate cosine inverse x. Now, if you recall, we have the derivation for cosine inverse x, which is minus 1 by square root 1 minus x squared. But we do not have a direct formula for integral of cosine inverse x. Now we need to do this by integration by parts. You might have come across this formula I equals, that's integration by parts formula. You need to rearrange this term cosine inverse dx as u and dv. Now this is v and this is u. The formula is given as u and v, uv minus integral v and du. If you're asking why do we use u and v, you can use any other thing, m and n, a, b. But generally in formula, in the textbooks, the formula is given as u and v. Now then, which do we assume it as u and which is dv? This is very crucial. The simple thing is whichever can be easily derived is u, because over here we are going to derive du with respect to dx. Okay, this is derived. Now here this will be integrated. So integration happens to this term and we will get v. So what can I take here? Can I take x? No, it's cos inverse x. It's a single term. Should I take cos inverse x? Let me see over here. Is it better to integrate it? No, not possible, because we do not know how to integrate cos inverse x. So here cos inverse has a derivative, so we have to take it as u itself, cos inverse x. And what about dv? What is remaining? Only dx, isn't it? That is nothing. That's 1 dx. So this is what's remaining. So I'll write again dv, integrate both the sides, and what do you get? Integration of dv will be v only, and integration of dx is x. And what about this? Du by dx is 1 minus 1 divided by square root 1 minus x squared. Now here, du by dx, right? Let's take this dx to the other side, because u terms, what exactly is du? That's what we want, right? We have to substitute entirely the substitutions in this formula. It's not u substitution. We are not putting it back over here. It's not possible. We are putting it over here. So du will be equal to minus 1 by square root 1 minus x squared dx. Now, henceforth, now this is the first problem, so I'm writing in detail, but you can skip certain steps. Instead of writing du by dx and then moving dx, you can directly derive this. Instead of u will be just du. Cos inverse is minus 1 by square root 1 minus x squared, and directly write dx because you're doing it implicitly. Du is separate and dx is separate. Or if you want to think this is with respect to x, it'll be du by dx, and then we are just moving it. It's fine. Anyway, it's the same thing you're getting. Now integrating dv, you'll just get v over here x. So this is how it is. Now what next? Look at this formula. Let me substitute. I'll write I is equal to, now what is the first term u? U is cosine inverse x. What is v multiplied with? V is x. Minus integral, what is v again? X. Times, what is du? Du is here, that is minus, I'll write a bracket, minus 1 divided by square root 1 minus x squared. Close the bracket. And then we have dx. It's all with respect to x now. So let us try solving this here. So here, now if you look carefully, what is happening? This minus sign can be removed out. This side, left side, it's done. X cos inverse x is done, plus integral. This x can be multiplied up over here. What happens is, you will get x divided by square root 1 minus x squared dx. Now, do we have any formula directly to solve this? No. But there is something called u substitution method. What is u substitution method? There is a relationship here. See, I know if I take whatever is inside this square root as u, then I can simplify. Otherwise, it's a very complicated term. Like integrating of 1 divided by square root. No way, that's not possible. Okay, so now what we do is, this much is done, still there's a continuation here, only this part now. I just change the color. Now this part is what I'm solving for. Here I will be doing u substitution. which is the complicated term. Inside the square root, if I have u, it's easy to solve. So I'll just do 1 minus x squared is equal to, u is equal to 1 minus x squared. Okay. So what is du? What I do is I'll derive this. Du is equal to 1 is 0 minus 2x, and with respect to x will be dx. Implicitly I'm deriving both the sides. Now then, what is known here? Dx. See, I'm entirely going to change this in terms of u and v and then solve it up and then put it back, whatever I have assumed. So what I'm going to do is, here, let me keep dx at one side and everything else to the other side. So it's going to be du divided by minus 2x is equal to dx. So I know this inside the square root term is going to be u, and then dx is going to be so much. Let me substitute. Now I'm just going to do it over here. So it'll be integral x, write it as it is, divided by square root u. Why? Because I've assumed it to be u. And then I have dx as du divided by minus 2x. Now here this x and x can cancel off, and I'm having minus 2 in the denominator. So I'll remove it out. Negative half is out. Integral 1 by square root u du. Now, what is this? This is 1 by u to the power half. You can use power rule here. So minus 1 by 2, take this up. Now see, it's all changed to with respect to u, so we can solve this normally, okay? So over here it's going to be 1, it is going to be u to the power minus half. I'm directly writing because 1 divided by u power half. When you bring it to the numerator, the sign changes in the power. This is actually 1 by u power half. Bring the denominator up, the power becomes negative. And now let's use the power rule. So what happens when you use the power rule? Minus half, it's outside. It's going to be u power half. That is negative half plus 1, right? Negative half plus 1 is positive half. So I'm writing plus 1 and divided by half. Now see, this half is in the numerator outside. This is down. This can cancel, or you can just write this as 2u because this 2 comes up in the numerator, right? Or you can just put it in the calculator, minus half into 1 divided by 1 by 2. This and this cancels. Now I'm going to write plus c at the end. Now I'm just not going to complicate it. It's going to be minus u to the power half. So this is the thing. What was u initially? What did we assume u to be? U was 1 minus x squared, isn't it? So that is what we will substitute back. This is equal to minus square root. Half, power half is basically a square root, isn't it? 1 minus x squared. So this is what we get. So now we will have to see, this is a detour from this part because we can't continue further. We have an integration over here, and that's not simple integration. We have to do this, and now we will put this solution back here. So this term, whatever. Okay, let me change the color again. What I'll do is this one. Now the entire thing, what is there, I'll continue out over here. That is going to be x cosine inverse x plus, but it's minus here, isn't it? Why? Because we got minus. So I'm just going to plus into minus. It'll be minus square root 1 minus x squared. Now plus c. After the entire integration is done, we can just write this plus c. So now this is the final answer. What happened? We did u substitute, sorry, not u, it is integration by parts, u and v, u and dv basically. We got them, and then we got what is u, du, dv was already assumed, and then we got v. We substituted in this formula, and then we got this. But when we tried solving here again, we got stuck because it became another complicated integral. So it's like a problem within problem. But this problem doesn't require integration by parts. All it requires is u substitution method. Because it looks a little complicated, just assume this to be u and then automatically see here. 1 is power 2. This will cancel off because whenever you derive this, because when you do u substitution, you derive it, you will get x. So that will go off. So that's where you can easily take this u substitution and simplify the right term, the integral only. We did it. See over here, whichever is mentioned in black, that is the thing. And that answer was minus square root 1 minus x squared. So then, now it's better you write it in order like up to down as you can go. Now this must be substituted back over here. And then we got the final answer, x cosine inverse x minus square root 1 minus x squared plus c. So this is how you need to write it out. You can see the final answer is, yes, it should be that. Let's just double, yeah, that's correct. Yeah, x cos inverse. Yes, that is what we have got. I hope this is clear. Now you can double check your answer using calculator. Once you did the correct answer, you can check it. How do you check it is very simple. You need a calculator. Here, first you need to check whether this is in radian mode. It's already, but if not, it is shift mode and 4. Now it's in radian mode. Now what I'll do is, you can choose anything first. But let me try this cosine inverse because cosine inverse has a restricted domain. Let's take shift cosine alpha x. And let me try 2 because usually I take 2. It doesn't work because it's not within the domain. If you take 0.5, it'll work, anything less than 1. So here you get 1.047. So whenever you have cos inverse functions like this, the domain is restricted at times. Even if it's a square root, and certain times we can't take any negative numbers, right? Similarly, here the domain. So whenever you see cosine inverse and all, if try 2, like take 2 first and check it's a math error. If you take 0. Let me go here 0.75. Sorry, it's not over here. Calc, and then let me type this. You're getting an answer because it's within the domain. Anything -1 to 1, it's fine because the range of cos function, you know, it's -1 to 1. You can even take negative numbers, but just take positive numbers. I'm just going to take 0.5 here. Whenever it comes to inverse function, I just take my 0.5. I got 1 by 3 or 1.0471. Now let me derive this answer. Only one correct answer which you solve. That must be correct. Now, if it is not, you will not get the same answer. Let's check this. X cosine inverse, again x, close the bracket, minus, I have not opened any bracket, only the original default bracket is there and it's closed. Cosine open and close, done. Square root 1 minus x squared here. Plus c, I'm not going to write. Why? Because it's a constant. See, now if I press 2, it's a math error. No, it's not going to work. Why? Because I assumed 0.5 here and it should be 1.047. Yes, absolutely, because this is the correct answer. That's how we check using calculator as well. Now I can be 100% sure this is correct. You can't directly do without the answer. So, if you did something wrong and you're getting a wrong value over here, that means you have done some mistake. So you can just go through the problem again. Now moving to the next problem, tan inverse. Again, let's write the formula. I is equal to u dv. That will be equal to, sorry, it's not integral. It's uv minus integral v du. That's it. Now what next? This is tan inverse x. Can I take it as integral as dv? No, you should derive this. U is tan inverse x. dv will be the remaining. What is remaining? It's only dx. So here it's going to be du, that is equal to 1 by 1 plus x squared dx. And here it's going to be v is equal to x, not dx. It's just x. Let's substitute in the formula. What is u term? U is tan inverse x. And what is v? V is x itself. Integral minus integral. What is v here? Again x. And what is du? It is 1 by 1 plus x squared. And then dx. So here again you can do u substitution, or if you recall the logarithmic rule. See, now I think so that will be a bit complicated. There are other tricks also, but if you want to go like a standard method, I'll just do u substitution, because in the first method I used u substitution. I won't do any other tricks. So I'm just following a uniform method, okay? So what this much is done. Let me just focus on the right side. Let me write it again. It is x tan inverse x minus x by 1 plus x squared dx. See, there are tricks. Directly I can tell the answer is ln 1 plus half. It'll be half will be there. 1 plus ln 1 plus x squared. But I'm not going to do those tricks because it's too many things to remember, right? So what we will do, this much is fine, but we cannot proceed further here. So what I'm going to do is I'm going to do u substitution only for this part. Now u substitution over here would be u is equal to 1 plus x squared. And over here we will have du is equal to 2x into dx. Now this, take it to the other side, it'll be du by 2x is equal to dx. Now only this part I'm going to solve. It is going to be x by u into du by 2x, cancels off. You have integral of u, that is, take it to the up, it'll be u power minus 1 du. Outside comes half, because this is the denominator, right? It'll be half over here. Now what next? Oh, sorry. Can I take this 1 minus 1? My bad. Here it is not minus 1, guys. It is 1 by u itself, because integral of 1 by u is ln u. Okay? Don't know what I just did. It's 1 by 2 over here. And now we will write half natural logarithm modulus u plus c. But I'm going to write plus c at the end, okay? Because there will be lots of constants over here when we derive over here. So we'll write it together at the end. So that is half ln c. Now we will put this back here. See, this goes back up over here. So we will continue from where we left off over here, right? I'll just continue over here. It'll be x tan inverse x minus half ln modulus u. Okay, so this is it. So this will be the answer. Now, okay, I forgot to write a very important thing. What was u over here? U was 1 plus x squared. So this is what you need to substitute back. Here it will be 1 plus x squared, not u in with respect to x. This plus c. So this is the final answer. I hope you're clear with it. You know, this is the method. First, you need to do what is u and dv. Once you get that, put it in the formula. And once you put in the formula, simplify how much you can. And then if you're stuck, you need to do u substitution. Do the u substitution over here, which you're done. And then put that answer back. This is how we can solve it up. Now we will see the next problem. I'll be solving all the problems. If you're thorough with this, you can just skip ahead and go to the next problems by yourselves. Now this is a different type. Now if you understand this problem, you can try all the remaining problems by yourselves. So 43rd one is sine square root x dx. Now how can you solve it? Because I cannot directly use integration by parts. I is equal to u dv, integral of u dv is equal to u minus v, sorry, uv minus, let me just write it properly, uv minus v du. This is the formula, and this is integrated, the second part. I cannot take anything as u, because if I take this as u, it's just going to be a complex term. You need to derive it again and again. It's going to be a little bit complex when you look at this, okay? Why? Because it's going to be chain rule and integral will be 1. But if you integrate this, then it's going to be again very complex. So what I'm going to do is I'm just going to rearrange this and simplify this further. And that is done by the substitution method, that is u substitution. But here, since we are using u, I'm not going to write u. You can write any other letter. Some write it as t, some write it as w, which is very, very close to u. Or you can write it as a, b, or anything. So now here, because of my handwriting, w, u, it'll be looking similar. I'm just going to use a. Now let me show you what I mean. I will assume this square root x as a. What happens? It'll be sine a. Sine a is something easy we can work with, right? With respect to a, that will be, okay? Then we will get everything back to normal terms. We will now just assume this for a minute. But I have square root x. Now what I need to do is, let me square this up, because you know I need to, if I change this square root x as a, I need to even change dx. I need to write it in terms of dA. So that means I need to derive this, isn't it? So what I'll do is, rather than complicating it over here, I will square this up. It'll be this whole square. So it'll be x is equal to a square. Okay. Now if I derive this, it'll be dx is equal to 2a into dA. Now it's easier, right? Now I know what is dx. I can write it in terms of a, and then sine A it becomes over here. So this question, what we did was we just rearrange this entirely into sine A multiplied by dx becomes 2a with respect to dA. Now we can write this 2 constant out. I'm just going to remove that 2 outside. That's out of the picture. A sine A dA. This is what we are to work with. We have to solve this now. You might see in the textbook W is written. It's fine, you can write anything, but just remember this is a variable, just a variable, another variable. So everything is converted with respect to A now. Now can we use U substitution? Absolutely, because sine A is simple to solve. It's easy to integrate. A is there, yes, we can easily derive this, and this can be integrated. So here I will do U, I'll choose U and dV value. So what I'm going to do is U is equal to A, because it will be simpler, and dV is equal to sine A dA. Another thing is, you might be thinking, why didn't I just assume this to be U itself? Square root x is equal to U and U squared. Then again there is U, right? And you might be confused further. So that's why I avoided and used a different term. Now here when you're choosing, don't choose sine A as U, because you can derive it. Yes, of course, you can even integrate A. But when you integrate A, it will be A squared by 2. It gets more complicated. So your goal is to simplify both the terms. Now when I derive this du is equal to, it will be dA. And what is the integration of this? It will be v is equal to minus cosine A d, it's done. dA is gone because you're integrating on both the sides. Now then I will substitute in the formula. The formula is u. What is the u term? A multiplied by what is v? Minus cosine A minus integral of what is v? V is again minus cosine A. And what is du? It is dA. So here I will write a little further. Minus sign outside, it's minus A cosine A. And what is minus and minus? It will be plus integral of cosine A dA. Now it is minus A cosine A. Integration of cosine A dA will be, it's like cosine x dx, okay? Integration of that will be sine. So it is plus sine A. It's plus C. Now it's not over. It's almost done. But don't forget. Okay, I forgot two things. I just forgot completely this 2 exists. Guys, yes, we are using the formula, but remember to apply this 2 here. So this was all multiplied by 2 because 2 was outside. That's absolutely fine, okay? This was 2. Now here as well, there was a term 2 outside, okay? This 2 was outside here. And here as well. See, now you can write plus 2c as well if you want. But then ultimately it's a constant sum. So you can just ignore that. I'm just going to write 2 here. Now what I'm going to do is I'll multiply this 2 inside. So it'll be minus 2a cosine A plus 2 sine A plus c. It's not over yet. Why? See, it's almost done. This 2 is taken care of. Everything is done. But we need to put back what was A. So here A is assumed to be square root x. So the answer will be minus 2 square root x cosine square root x plus 2 sine square root x plus c. So this must be the final answer. There's nothing else. Please guys, don't forget this too, I remember before as well many students tending to forget this. They take this 2 out, yes, over here when they solve it, and they just completely forget it. They solve over here without this 2. It's almost correct, but you're missing a multiple. Sometimes this number can be 3 or half. Please remember this. Don't do that mistake in exam. What I did was it's good that I did that mistake, so you don't do it in the exam. So that is the final answer. You can see here they have written 2 outside itself. That's also absolutely fine. Just like this, they have substituted back over here. However you write, you're right. It's a writing exam. However you write whichever form, it's fine. Now, what about this one? Again, we need to simplify this. You have to do U substitution first, and then, now I'll call it as A substitution. So I'll consider square root x is equal to a. And now to make this easier, because I need dx, I need to derive it. Look, I can derive this as well. It'll be 1 by 2 root x into dx. It's just getting more and more complicated, right? So better way would be I'll square both the sides. It'll be x is equal to a square, dx is equal to 2a times dA. This is much simpler. And now here this becomes integral of e to the power a 2a dA. Now again we have a 2 outside and a times e to the power a dA. And this is what we get. Now what next? Again the same formula, integration by parts. So let me write over here I is equal to, I'm just going to write the formula. I'm not going to write integral u dv. Just that uv minus integral of v du. And how do we substitute? Now we need to first assume what is u and what is dv. So I'll use u as, see, if I use u as ea, it's not going to complicate it, nor it's going to simplify. But if we take a as dv, it's going to be a squared by 2. So just choose this as a. dv, let's choose it as ea, because this doesn't make a difference. It's the same integral and derivative of exponential to the power variable. It's the same thing. See, v is going to be ea itself. No change here whatsoever. But here, du is equal to dA. It became so easy, isn't it? If you swap these, then it's just going to be more complicated. Now, we will substitute in the formula. U is a, v is e to the power a. Now, what did I forget? I'll first write the 2 because I did forget in the last time. So here, this is what we are solving now. 2. Integral of this is using this formula. A e to the power a minus integral, what is v? E to the power a. Whenever you write this term, you can directly write it after integration. It's the same terms, cv and v. And du is dA. Now let's solve it up. It's going to be e power a, or you can write a e power a is the same thing, minus e power a. That's it. Plus c. Why I'm writing plus c out? You can write 2c, but I've told it's the constant term. You can just add at the end as well. Even if you don't write it at the end, just add a c. And now let's multiply this inside. It's going to be 2. I'll write a first. E to the power a minus e, again 2 e to the power a plus c. And what was a actually assumed to be? A was e to the power square root x minus 2 e to the power square root x plus c. So this is the final answer. It was a very simple problem. So this is it. Now you can write x to the power half as well, but now here we are writing square root x. Okay, I forgot one important thing. When I saw the solution set, I remembered. Look here, this is a. I need to substitute it back. All a's will be in terms of x. It should be all in terms of numbers and x only. Okay, so even this 2a, it should be substituted back as square root x. Now it's done. Or you can write it as x power half. X power half and square root x are same, up to you. That's how we do this. And now we get, I think so this is a little bit more complicated because it is natural logarithm x over here in the middle. Now why? Because ln, whenever you have functions ln, it recurs. When you use the integration by parts, you have to do it not only once. This formula is there, right? U v minus v du. This must be applied once again because another part will be stuck, and then again you have to apply this. Now let's solve this up. So what are you going to choose a as? Sine a. So what is inside? Instead of sine x, it is ln x. So I'll choose a as ln x. Now here, remember, if I start deriving it, it's going to be 1 by x, and it's going to be more complicated because I'll have an x term remaining. Now if you're thinking, why don't I do like this? 1 by x dx. Now yes, absolutely, you can do this. This goes to the other side. This is a wrong method because I'll show you why it is wrong. Now look here, integral sine a. Very good. What is dx? It is x times dA. Now this x is there. You can't solve that. That's unaccounted for. You can't solve with two different variables. We can only solve with one variable, right? So therefore, you cannot derive both the sides like that. So that is my intention, to make x alone. Now, how do you remove this natural logarithm? Take e to the power exponential on both these sides. Exponential and ln cancels. So it's going to be e ln x. This cancels and x comes down, isn't it? E to the power a is equal to x. Now I'll derive both the sides. When I derive, it's going to be the same thing, dA, that is equal to dx. Now when I substitute it, it's going to be sine a ea dA. Everything is in terms of a. But if you choose otherwise, it'll be x and you cannot proceed further. I'm sure you might be thinking, what exactly should I take it as u or dv? Which to choose? Here, remember, whenever you have e to the power x and sine x, choose e to the power a as u. I'll tell you why. We will see. You can try it by yourself, but let's see this as well. Now here what I'm going to do is u is equal to e to the power a. This I'm going to derive du is equal to e to the power a and dA with respect to, implicitly we are deriving. What about v? That is dv is equal to, remaining term is sine a dA. So v is going to be minus cosine a. That's it. Now we have to use this formula. I'm going to write it over here in steps. So let me just change the color here so that you understand whenever we assume it'll be over here. So u is e to the power a, multiply it with, what is v? It is minus, I'll write minus outside, cosine a minus again cosine, okay, this one integral, right? Minus is there in the formula and cosine is also having minus, so I'll just write this as plus now itself. Why? Because it'll be 2 minus and minus, it'll be plus. Minus already in the formula and minus, v is also minus. It becomes plus cosine a. And then what do we have is du, which is equal to e to the power a dA. I hope this substitution is clear. Now, let's substitute again. What are we substituting? Let's rearrange, sorry, not substituting it. This entire thing is basically I. Is that okay? Because we are deriving with the I, right? I term. So this was the origin. What is I exactly? I is this term here, what we have. Okay? This is I. Now let me rewrite this a bit more clearly. No, not rewrite more clearly. I'm sorry. I need to see the right part. Integral cosine a e to the power a dA. I'm stuck again. It's just like a question. But over here, instead of sine, we have cosine. So I have to do this again over here. Let me show you. Now I have to assume u is equal to e to the power a, du is equal to e to the power a dA. And what about dv? Instead of sine, we have cosine a dA. And then we get v is equal to positive sine a. Now let's substitute over here back. Now let me again change the color. Why? Because now this was the first substitution and then we got this and then again this right side was substituted over here. Now initially this was substituted first, second, and now I'm going to write left side is done. Ea cosine a is done. Plus again this part will be used the same formula. U is equal to e to the power a. V is sine a minus integral minus, sorry, it's plus now, plus sine a. And what is du? E to the power a dA. This was it. Now, since it's just minus and plus, I do not need those brackets. It's no multiplication. If there was a term outside, these brackets are very, very important. But I'm now going to just remove it. Why? Because it's not important. Next, what can you do? If you if you're gonna keep on doing this, it's just gonna recur. Next is gonna be again cosine sine. It's just gonna be the same thing. So what are you gonna do is look at the question for a minute. It is the same thing, and that is I, and this side is also I, isn't it? Now what I will do, I'll write this I is equal to minus Ea cosine a. This is minus over here plus Ea sine a minus this integral. With this integral, this is just our question I, that is I, we are applying the formula for that. So I'm getting back recurring term as I. I'll keep on getting that. So I write it as I, that is what we have got. So we will take this to the other side. Minus I to the other side will become I plus I is equal to this entire thing. Again, minus e to the power a cosine a plus e to the power a sine a. That is now this 2i, right? It's I plus I. That is equal to 2i. That is equal to minus ea cosine a. Now, in writing, you need to write in detail, isn't it? You can't just skip. You can write two inverted, like you can do mention like that, but it's better to write in detail. So then I will take this 2 to the other side or divide all the terms by half. So I will be equal to minus half e to the power a cosine a plus half e power a sine a. Now we are almost done. Now we will substitute back, I'll just change the color here. Now if you're thinking, okay, e to the power a is what exactly we assume? Ln x. You can do that and then it'll be cancelled, but instead of that, what is e power a? It's x. So here I will be minus half x. What is cosine a is? Cosine of ln x plus half x sine ln x. Don't forget the plus c here. All there'll be plus c. Once you did the integration, right, there'll be plus c. So this is the answer. So it is basically negative half x. Now you can write this minus half outside itself. It's fine. But these terms are very important. This term and this term. So this is how we solve it up. Here we had to do the integration by parts twice, and then we got the answer. So here we can see that is the answer. No, it's continued. Okay, this is the answer. Yes. Half. Okay, now what they have done is they have written the negative part right side and sign positive part sign is written first. It's absolutely fine. Let's go further. The next one, it's similar to what we had done just now. You can try solving these problems by yourselves, but I will solve it anyways. You can pause the video now, solve it, and then continue watching to check your answers. Here again, first let us assume a to be 4 plus x squared. Now I'm not going to take ln of 4 plus x squared. Why? Because here this is a term, natural logarithm is a single term. So I'll just take a as whatever is inside that. Instead of natural logarithm x, we have this term, right? So now here, see, I can see there is x. So in this case, I'm not going to rearrange, right, make it, or, take the square root and all. No, if I derive this directly, because this is power 2, I'm going to get x over here. That'll cancel off. See, whenever you have x multiplied to it, strategically leave this right side as it is. Now I'm going to derive both the sides. dA is equal to constant term gone. It'll be 2x times dx. Now we want only dx. Take this to the other side. dA is divided by 2x. This is equal to dx. Now look at this rearrangement. X ln, what is this term? It is a. Dx is dA divided by 2x, and this x and x cancels off. You get to write this half outside. Integral ln a dA. Isn't that very simple now? Do you have any integral formula for ln a? What is integration of 1 by x? It is ln as, but we do not have any formula for this. So we are to do integration by parts. Let me write the formula here again. Integration by parts, I is equal to u dv. That is integration of these two terms will be equal to u v minus v. This is integral du. So here we need to assume u and we need to assume dv. So I'm just going to write over here u is equal to ln a. Why? Because we know the derivation du will be 1 by x, sorry, 1 by a, not x, because we're writing everything with respect to a dA. This is the derivation. What is remaining over there? There is nothing. That is 1. So dv will be equal to dA, or v is equal to a. That's it. So I'll substitute over here. It'll be half. And the formula integration is gone. Why? Because I'm applying the formula. Now what is u? ln a multiplied by v is a, minus integral of v is again a, into du is 1 by a dA. Now this cancels off. What happens? it'll be half a ln a minus, what is integration of 1? It's basically integration dA or 1 dA. So let me write it again in the next step. Ln a, integration of nothing is, if there is just dx, it's x, isn't it? The same way we have a dA over here, so it'll be minus a. That's the answer. Now we can multiply this half inside. I'm just going to leave it outside. That's fine. This is the correct answer itself. So what was a assumed to be? A is 4 plus x squared. So here it's going to be half. Outside it's 4 plus x squared ln, again 4 plus x squared minus 4 plus x squared plus c. Now here there are a few other things. You can even take the a outside and it will be ln minus 1. But see, it's writing exam. This is correct. This is enough. What I'm saying is, instead of this, you can write a and a common out. So it will be a by 2 into ln a minus 1. And now you can just substitute a over here and over here. Absolutely fine. You can multiply this half. Everything gives you the correct answer itself. Even if you just substitute over here and over here a values, that's also correct. So it's up to you. This I just showed you another way. Now this is what we would generally write. And that's the answer, guys. Let's see how it's written. Okay, over here they have multiplied. No, they have not multiplied. Okay, yeah, half is outside. What happened here is minus and minus. See, they have multiplied this minus sign inside. It's minus 4 and minus x squared. That's the only thing here in the final solution. That's fine. You can stick to what we had written. Now we have e to the power 6x, e to the power 2x. Seems a little bit complicated, right? Now it's not easy. We have to do twice because over here we can see there's exponential and sine. The integration by parts will be 2 times. But how do we start solving it? Whatever is inside the sign, let's assume it to be a. So a will be equal to e to the power 2x. But now the issue is we have 6x. How will you get a relation for 6x from this? You can, if you cube both the sides, if you make power 3 both the sides, it will become a power 3, and over here the whole power 3 times 2 will be 6. So it's e to the power 6x. So this is how we do it. Now we can derive both the sides, because our main goal is, if you now derive this, this will be there and this can be cancelled off. We can simplify the equation. Now let me show you derivation. It will be 3a squared, sorry. 3 comes down, a power 2, dA is equal to e to the power 6x dx. Now what is dx? Just this moves to the other side. It's basically, okay, that's gone. I've written it down over here. So now let me substitute it back. The given question becomes integral e to the power 6x sine a dx is, here it is 3a squared dA by e to the power 6x. Now this cancels off with this, and so it simplifies in order to become 3. I'll write outside 3 is a constant term. A squared sine a dA. Okay, now it's a little bit easy. Okay, I thought, okay, it's not sine and e to the power x, so we'll have to do it only once, integration by parts. But then you can see the power is 2, so we have to do it twice no matter what. I'll tell you now. So this is the thing. And now whenever you see such things over here, let's assume over here, and I'll write it down over here. The formula is I is equal to u v minus v. This is integral du. Now I'm going to change the color. Why? Because we are to assume for this. What assumption do we take? What is u? U should be a square itself, and du is equal to 2a dA. What about dv? dv is equal to the remaining thing, that is sine a dA, and we get v is equal to minus cosine. This is minus cosine a. That's it. Now substitute back over here. It is 3 multiplied by, what is u? U is a squared multiplied by minus cosine a. Then we have to write minus again. Now minus cosine, right? Integral of minus. So I'm taking this minus outside, will be plus. Okay, because whatever minus sign, we take it outside the integral anyways, right? So I'll just change the sign now itself. It'll be cosine A. And what is du? Over here it's du, that is 2a. Now I'm just going to write 2 outside over here, outside the integral. 2a dA. So we have a 3 out, then inside again there is a 2 out, 2 over here. So you can do multiplication here and then, keep it, but I'm just going to leave it like this itself. Now what we will do is we will have to solve this part. See, from a squared we got a. Now if we solve it once, then we are just going to get a single term, constant term, and then we can solve it up. So here now, for the second time, that's going to be over here. What do we write? U is equal to a, du is equal to dA. And dv over here becomes cosine a dA, and v is equal to sine a. Now let's substitute. Let's see here. 3 is outside. And there is minus a square cosine a. Then we have plus 2. Now this integral, see, I'm going to use small brackets now. What happens? This integral is solved by u v. That is a sine a minus integral. What is v again? It's sine a. What is du? Just dA. Now we can easily solve it up. Why? Because now no more branches. See, this one, we put it over here. This one over here. Now we will solve it. 3 minus a squared cosine a plus 2. Let me write it outside itself. It will be a sine a minus, what's the integration of sine a? It is minus cosine. So again, it will be minus cosine. That's it. But this minus and this one minus out, it will become plus. So I'm writing plus directly. So this is what we get. Now we can just substitute back whatever is a. Just substitute back, it is enough. You can leave it like this. But if you want the actual coefficients, I'll just multiply this 3 inside. So if I multiply this 3 over here, it's going to be minus 3a squared cosine a. So that's the first term. And then what next we have is here when we multiply, it will be 6. So it will be plus 6a sine a plus cosine a. Now you can even multiply the 6 over here and over here. Anyways, we'll just do that. Or we can directly substitute now because this is enough, I guess. It's just going to take more time. That outside brackets are not required anymore. Minus, what is now a squared? See here, you have, that is a, right? What will be a power 2? A power 2 will be e4x. So here, I'm just going to write 3. A power 2 is e to the power 4x. Cosine, what is a? E to the power 2x. 2x. That is the thing. Plus 6. Again, a only, that is e to the power 2x. Sine e to the power 2x. E to the power 2x. Plus cosine e to the power 2x. That's the final answer. Don't forget plus c. Okay, since we solve the integral over here, plus c will be added. I have done the derivation wrong. Look here, guys, I have missed this. But it's fine, only the coefficient is the change. I'll tell you what is the change. Look, what is the derivation? See, a3, I'll write it out over here. We have a3 is equal to e to the power 6x. Derive both the sides. It is 3a squared into dA, that is equal to e to the power 6x. Chain rule, 6x multiplied by 6 dx, isn't it? I just completely forgot that. Then we take it to the other side. It's going to be 3a squared dA divided by e to the power 6x multiplied by 6. So that cancels off and it's 2, 1 by 2. So this is basically a squared dA by 2 e to the power 6x. So here instead of 3, we must have divided by 2. It's half that has been multiplied. So the only change is you're multiplying throughout by half. That's the thing. Nothing else. So everything is correct. Look here. All you need to remember is this will become 1 by 2. Why? Because I chose I forgot about that. I chose the coefficient wrong. This will be 1 by 2. I just edit it over here itself. It's 1 by 2. This is also 1 by 2. Everywhere 1 by 2. So now what we are multiplying is 1 by 2. And here when we multiply 1 by 2 inside, half multiplied by 2 is 1. So I should remove that. It's half. To re-record entire thing, I'm just tired now, so that's why I'm just doing this error management, I can say. Half multiplied with 2, it's 1. So that's it. So here, this is the answers, and here we go. So that will be the final answer. It is negative half e to the power 4x cosine e to the power 2x plus e to the power 2x sine e to the power 2x plus cosine e to the power 2x plus c. Let's just double check it. And okay, we are over here. That's the correct answer. Yes, half. Yes, that's it. These two are positive. So only mistake, only error was the coefficient. When I derived, I forgot to do the chain rule. See, it's e to the power 6x multiplied by 6. Don't forget the chain rule. And here you go. This will be the correct answer. Twice we need to do integration by parts. Now then we have another similar. See, we have done similar problem. It's just that we, instead of a square root, we have a cube root. So that's fine. It's same thing. First, let's assume a to be cube root of x. Okay. Then what we do is to remove this cube root, because there's no multiplication by any cube root or anything. So I need to remove this. I need only dx. Let me cube both the sides. It'll be a to the power 3 is equal to x. 3a squared dA is equal to dx. Now let me substitute it over here and get this simplified. It's going to be integral cosine a dx will become 3a squared dA. Now let's rearrange and write this properly. The 3 outside, it will be 3 integral, what's remaining is a squared. I'm going to write first, cosine a dA. I hope this is okay. Now again, here you can see it's a square and cosine a, so we will have to do it 2 times, because once we'll dissolve it to power 1 and then second time will be a constant. Now here, let me do this. We write the formula. It's uv minus integral v du. And what is u? U will be u a square here. So du is equal to 2a dA. And dv is going to be cosine a. See, now don't get confused. It's not du. Du is already found out. We choose dv, not v as well, because the remaining term must have, the integration must be done over here. So it'll be v is equal to sine a. That's it. Now I'm going to change the color so that you can differentiate it. Now the next term will be over here. That's 3 multiplied by, now let me just double check the coefficient. Yes, it's only 3. Yeah, this time it's correct, because I wrote 3 last time and that was supposed to be half. Now what is u? U is a squared times sine a. That's done. Minus integral. What happens over here? I'll just write the integral a little far away, because we will have a coefficient, right? What is v? V is again sine a. What is dA? Du. Sorry, second part is du, right? This is the formula, du. What is du? 2a dA. So I'm going to write this 2 outside. And what is remaining? A and dA. So now again I need to use this integration by parts. Now I'm going to use u is equal to a. See, it's reduced now. Du is equal to dA. Now it's a constant. I'm not going to have this recurring a variable. So I'll have a number and I can easily use the rule of integration and solve it up now. Now what is dv? It is sine x. Sine x d. It's not x, sine a dA. And v will become equal to minus cosine a. Now let me substitute back. Let me just change the color here. So when I apply the rule again, only for the inner part, that is outside is same, sine a minus 2. Now this part over here becomes a times, see, it's minus, because minus cosine, right? I'll write minus a cosine a minus integral, again minus, right? So I'm just going to write this as plus. Okay, I'm just changing the signs here itself because there's minus. I'm making this plus cosine A multiplied with du. What is du? It's just dA. Now this is it. So here, left side, all these terms are fine. It's already simplified. You can't simplify anything further here. Now you can multiply this 2 inside. What I'm going to do is I'm just going to do it now itself. Minus 2 multiplied here will be plus 2a cosine A. And then this minus 2 over here will become minus 2. What is integration of cosine A? Integration is sine A. That's it. Plus C. See now this 2 minus 2 is multiplied to this term. What is the integration? That is sine A. So that's multiplied to sine A only. And now what I'm going to do is I'm just going to substitute whatever we assume A to be. See now it's cube root. You can write it as cube root itself. But here there is A squared. So let me take that for a minute. It is cube root x, right? So what is this? A is equal to cube root x can be written as 1 by 3. Anything over here root. If it's square root, it's 1 by 2. If it is over here 4, radical 4, then it's 1 by 4. Now let me square this up. If I square this up, what's going to happen? A is equal to x 2 by 3. Okay, that's the power. You can write A as x 1 by 3 or this cube root. Or if you want another way, this is A squared, okay? Or A square can also be written as x square outside is cube root. Anything, you can choose this or this, up to you. This or this. So here 3 is intact over here. You can multiply this 3 inside. See, this I have multiplied because it'll be too many brackets inside, right? But I'm just going to leave the 3 outside. You can multiply n, and then this is going to be 6 and 6. It's up to you. If you want, you can multiply it inside. A square, I'm going to use this form. You can write x square by 3. That is also fine. I'm just going to use radical form itself, x square. So it's sine A is cube root x. That's done. Plus, see, this is not sine cube. It looks like that, right? Okay, so what I'm going to do is I'm not going to write that form because it looks like sine cube root x. That is absolutely wrong. So I'm just going to write 1 by 3. I hope you're understanding because when I was writing sine cube root x, it looked like as if it's sine cube x. So that is the reason why I'm writing x power 1 by 3 because they are the same thing. 2. Again, x power 1 by 3 cosine x power 1 by 3 minus 2. Minus 2 is fine. Then sine. You can multiply this. Remove the brackets. It's fine. It's a single term. X power 1 by 3 plus c. And you don't need this outer bracket. Oh, no, you need it. Sorry, why? Because there is 3. Okay. Over here also you can write, I'll write the same form every way. It's going to be x power 2 by 3. Or you can write any of this. So that will be the final answer. We have substituted back what was A. So here we go. Now, how did they get x? So here, yeah, they have written 3. Okay, 1 second. Let me just check this. 3u squared. Yeah, this is sine u minus 6. Yeah, this is what we have got as well. When we integrate, then this became sine. And all of a sudden they have put y to the power 3, which is wrong. This is wrong, I believe. So let's just double check it in the calculator, okay? What I'll do is, I'll check my calculator because I'm certain my answer must be correct because I think so this is an error over here. It should not be u to the power 3, it's u to the power 2. They by mistakenly wrote u to the power 3. So no worries. What we'll do is, check both of these in the calculator. So here first I'll write this given question. What is it? Cosine. Now it's cube root, shift and this, or you can write this shift and this symbol and then you can type in the 3. Alpha x, close the bracket outside. I'll calculate it at different values. I'll just choose 2 and it should be 0.305. I'll just remember, I'll keep that in my mind. And now I'm going to derive this, shift dy by dx. Now this is 3 multiplied by alpha x to the power 2 divided by 3 multiplied with, okay, not over there, not the power, this one, multiplied with sine, it's sine x. See how you can write sine x to the power is, after writing sine x, just use the power 1 divided by 3. Now you need to be very careful while closing the brackets. Okay, now it's closed here. Now whatever I open for 3, the first term, it goes until the end, so don't worry, I'll just close it at the end. See here, sorry, the first one is automatically closed. I'm talking about this, the next one. Okay, it's closed at the end after all the terms are written. And then we have plus 2 x is over here, alpha x, not shift x, raised to the power 1 divided by 3. And then what do we have is cosine x raised to the power 1 by 3, close the bracket. And then we have minus 2 sine power 1 by 3, sine x, sorry, it should be sine x raised to the power 1 by 3, close the bracket over here. And then I'm going to close the bracket for the 3. And this is 2, it should be 0.3. Let's check. Yes, it's 0.305. If you do this solution, you will get a wrong answer. Let me just show you over here. If I just change this, only that was the error, to power 1, because x power 1 is x itself. Look, it must be different, and that is wrong. So what we got over here, this is the correct answer. Please make a note of this. And now the 49th one, it's integral 0 to 8. This is definite integrals. Now we have to rearrange, solve it by the methods which we used. We have to use integration by parts and all. But here the thing is, limits change. Now first, you can't directly integrate by part. It's a complicated term. So let us assume this. Again, it's a cube root. Just now we did it, right? A is equal to this cube root thing, right? As A. So here A is equal to x power 1 by 3. Let me write that. And let us take the powers, both the sides as 3. So it's going to be A power 3, that is equal to x. Why? Because it will be 3 divided by 3, that's 1. Now let me derive both the sides. It's going to be 3a squared times dA, that is equal to dx. Now let me substitute it back over here. This is going to be some limits, because the limits are changed. I'll tell you in a minute. But this is e to the power a. What is dx? It's 3a squared dA. That's it. And what next? Next, now you can write the constant term outside 3. And then let me just rearrange this. E to the power a and a squared dA. Now how to write these limits? That is very important. Let me show you over here. Initially, the limits were 0 and 8, isn't it? So what did we assume? We assumed this term, but let's take the simpler one, x, because we know this is with respect to x. X is 0, 8. So what was x value originally? Assumed as x is equal to a to the power 3. So at x is equal to 0, why I'm taking x is equal to 0? Because this is the lower limit. What happens here? 0 is equal to, let me write this, 0 is equal to a to the power 3, or I'll write a to the power 3 is equal to, here a power 3 is equal to 0. I'm just writing this as first. What is that a value? A is 0 itself, because take the cube root on both the sides, it'll be a is equal to 0. But now what happens when at x is equal to 8? Now this is the thing. If you see carefully, it's going to be a power 3, 8 here. But luckily it's cube root. Let's take cube root on both the sides. Cube root over here, cube root here. If you put in the calculator, what is cube root of 8? It's 2, isn't it? So the new limits formed are 0 to 2, guys. This is how we get these limits. Now the most important thing is changing the limits. This is a very crucial step. Now this is what we will work with. Sadly here it's a power 2. So what happens? We have to do it twice, just like what we were doing it. Integration by parts twice. I'll write the formula here itself. It is uv minus integral v du. Now then, Let me just change the color. So I'll assume for this one, u is equal to e to the, sorry, not e, it is always a to the power 2. So du is equal to 2a dA. dV will be equal to whatever is remaining, that's ea dA. That means v is equal to e to the power a. That's it. Now we will substitute 3 will be left outside. I'm not going to take it inside at all. And now see the limits when we are applying, I'll apply it at the end because we'll try and solve it up. Actually, you can write, I'll show you what way you can write it, the real way. That is, first, let's apply the formula. It's a square e to the power a. Now you need to write over here limits 0 to 2 because we applied this rule, right? Integration rule. Then we keep on writing. But instead of that, what I'm going to do is I'm just going to write this entirely at the end. Then minus, what is this again? Integral. What is the limit again? It is 0 to 2, the new limits, not the old limits, not the limits of the question. Now, if you write 0 to 8 over here, then the answer will be entirely wrong. And now next what we do is we substitute the formula here. No, not the formula. Yeah, whatever is remaining, sorry. E to the power a into du is 2a dA. Now I'm just going to mark this as 2 and 0. So whatever happens, how much ever you solve, we have to just apply at the end. Or even if you don't write that, it's fine, guys. Okay, it's fine. Just at the end, you need to apply these limits at the end, right? That time if you do it, it's enough. But remember the newly formed limits. Now this is okay, but now again we are stuck with this. So this 2, I will write it outside. It's minus 2. I'll write it out and I'll remove it from here. Okay, I just wrote that 2 outside. And what next? Again, I need to assume over here that is u is equal to a du is equal to 2a dA. In fact, we did the same type problem, just a while ago. dv will be again e to the power a dA and v is equal to e to the power a. Next, oh, now look at my sloppiness. It's only dA, it's not 2a, it's only dA. Now, this is going to be 3 times a squared e to the power a minus 2. I'll leave it as it is. And what happens? A times e to the power a minus integral e to the power a times dA. And the limits will be there. Now let me write out. You can multiply this 3 inside. This is going to be 6 here. In fact, I'm going to do it because anyway, it'll be too many limits otherwise. So now only I'll do it. 3a squared e to the power a minus 3 times 2 is 6. Because why I'm multiplying over here is because it's definite integral. We have to simplify at the end. You can keep it out also, it's fine. But, I'm just going to simplify it over here. And here we have 6a e to the power a. That is fine. That is, okay. Let me put this bracket because this minus 6 is outside because these two terms are there, right? Let me solve it up. What is e to the power a dA? It's the same thing, e to the power a itself. And then all these terms, guys, will be having the limit 0 to 2. So there's upper limit and lower limit. And what next? I'll write these terms 3a squared e to the power a minus 6a e to the power a, and minus becomes plus 6 e to the power a. Not a, it's e to the power a. And the limits for all this is 0 and 2. Now, how do we apply the limits? When we apply the limits, it's always upper limit minus the lower limit. Now, whenever you have this variable, see, look at this variable a squared. Lower limit is 0. So what happens when the 0 is multiplied with a? It's 0 squared. This term is 0, gone. 0, gone. A is there. But here it's not gone because e to the power 0 is 1, so 6 will remain. So remember, don't just dismiss the below term because it's 0. You need to use upper and lower. So now I'll solve first. First is always the upper limit. Wherever a is there, you should put this 2. So 3 into 2 square e to the power 2 minus 6 into 2 e to the power 2 plus 6 e to the power 2 minus, now what happens here? Entire this thing is minus. The sign actually changes. Some of them don't put this bracket and all. They just write this sign change. minus the lower limit. This minus will become plus and this minus. Now I'm not going to write everything. Why? Because it's 0. First term is 0. Minus again, second term is 0. But plus, what is this last term? 6e to the power 0. Now let's simplify. It is 2 squared is 4. 4 times 3 is 12. E to the power squared. Then we have minus 12. Okay, this is going to cancel off. Plus 6e to the power 2. Now this is cancelled. We have 6e to the power 2 minus, because this plus and minus is minus, 6e to the power 1 is 1. So answer, the final answer, I'm just going to write it out over here. 6e squared minus 6. That must be your form. And you can double check this in your calculator. Let's take our calculators. Over here, the given question is shift e to the power, let's take the cube root, shift and the symbol, x, dx is already there. The limits are from 0 to 8. What is the value? You get a numerical value, but that's fine. Whatever the value you get should match here. Now, it's not, you will never get like 6e. You'll get a value and then simplify this. It should match up. It's taking quite some time, because the reason is this cubic function, the root functions, right? It takes time when there are root functions and stuff. So anyways, let's see. Here we go. It's 38.334. Now, what I'm going to do is just write this a squared minus 6, and it should be the same thing. It's 38.334. So this is how we can check. Yes, this is absolutely correct answer. Okay. So here we go. It is 6e to the power 2 minus 6. So the 50th problem here now, again, is the same thing. But looking at this term, I can see there are two terms. I'm not gonna, you can directly use this one, what is that, I is equal to formula. Why? Because I'm not going to simplify it further. It's already simplified. There's nothing you can simplify it with. It's tan inverse x. It's not complicated over here. You can't assume anything, like you can't assume tan inverse x as u. It wouldn't make sense. So all you do is do integration by parts. That's it. And directly you will get the answer. That is uv minus v integral u v du. That's it. So now here, let us assume what is, now this is very important. Tan inverse must and should be assumed as u here. U has to be tan inverse x, because du is equal to 1 by 1 plus x squared dx. And what about v, dv? That is x. So now this is going to be it'll be little complicated. That's going to be v is equal to x squared by 2. Doesn't matter, we have done the assumptions correctly. Now let's substitute in the formula. What happens when we do it in the formula? I will be equal to u is tan inverse x, v is x squared by 2. That's fine. Minus integral. Again, we have x squared by 2. And what about this part? Next one is multiplied by du. That is 1 by 1 plus x squared dx. Now, this is where it gets tricky. Look, let me write this out. Tan inverse x, x squared by 2. Minus, let me take this 1 by 2 outside, half is outside. What is remaining? It's x squared by 1 plus x squared dx. Now this is x squared, and down also we have x squared, but we don't have 1 plus. We can't split the denominator. Over here there is only one term in the numerator. If it was, say for example, 1 plus x squared by x squared, we can split it out. But that is not the case here. What you need to do is, see, I need to get 1 plus x squared. Fine, let's do that. I'll just focus on this term here. See, I have x squared by 1 plus x squared. I have to write 1 plus. That is the extra term. 1 plus. If I do that, how can I balance it? I've added 1, so I should subtract by 1 as well, right? Then it's okay. Basically, it's 1 plus 1 minus 1, 0. So it's x squared by 1 plus x squared itself. So that is what I'm going to do now. I'm just rearranging this as tan inverse x. This left side is the same thing. But here minus half what happens here? You do 1 plus x squared plus minus 1 divided by the entire thing 1 by x squared dx. Now can I write this as 1 plus x squared by 1 plus x squared minus 1 by 1 plus x squared? Absolutely, because the denominator is split to this and to the right side. It's nothing wrong in this because this is just going to be 1 minus 1 by x squared, and I'm going to get the same thing. The answer will be the same if I simplify this to the original, but I'm just rearranging this. I'm adding and subtracting, I'm manipulating the given question, the numerator, and now I split it out. This is one single term. Why? Because this cancels out to be 1, and what is this one? It's 1 plus x squared. So that is my intention. So now what I'm going to write is tan inverse x squared by 2 minus half. Here, integration of two terms. Integration of which two terms? That is 1. See, this half is being multiplied here. I need to split it out, right? See, initially this will be like this. Now, I multiply this integration to this minus multiply this integration as well to both of these and dx. Okay, so I'm directly going to write this here. First part, it'll same thing. It'll be 1 integration of 1 dx minus, okay, now this is minus multiplied here. We are multiplying with minus, so first term will be minus, but this already has a minus. Can you see? I'm multiplying minus half, right? The first term will be minus half. The second term already has minus, so it's going to be plus half integral. So it's going to be integral 1 by 1 plus x squared. I hope this pen is not dying on me now. 1 plus x squared, and that is dx. So this is how to get the above transformation. Now we have 1 plus x squared by 1 plus x squared. Here, that term becomes 1. Minus 1 by x squared, that remains. But we are multiplying with minus half integral, right? The first term becomes negative minus half integral 1 dx. Second term minus was already there. It became plus this much. Now, can we simplify it? Yes, we can simplify a few of the terms very easily. This is already done. X squared by 2 minus half. What is x? What is integration of 1? It's x minus half x. That's it. What about this term? Half, if you remember, it's tan inverse, right? Derivation of tan inverse is 1 by 1 plus x squared. But now we are integrating it. Integration formula is this inverse integration, right? It will be tan inverse x plus c. So now this is it. This is the final answer. But now what is the most important thing? Now I'm not going to write c because it's definite integral. We know the values of the limits, right? I'm going to apply the limit 0 to 1. I've not written anywhere limits up, but now I'll apply it. So this is tan inverse x, that is 1, tan inverse of 1, multiplied by 1 square is 1 itself, 1 by 2 half, minus, again, half. Why? Because 1 times half is same thing, plus half into tan inverse of 1. And then what we do is subtracted by what? Everywhere tan inverse 0. But now this is going to be 0 itself because I have 0 squared. It will be 0 minus again 0 half multiplied by 0 is 0. Now tan inverse 0 is important. It's plus half tan inverse of 0. I've applied the limit. We'll just put in the calculator now because it's inverse function, right? Now tan inverse 1, it might, because we are using radian, you might get it in pi, or you can write in degrees, but it's better to use in pi. So let's use radian mode and solve this. So what I'll do is tan inverse, shift tan inverse of 1. Now it's in radian mode, the answer is pi by 4. Okay, now this is pi by 4. And what about tan inverse 0? Tan inverse 0 is 0, so this term is also 0 itself. Yeah, okay, I didn't know why I did not write 0 directly. Now when I saw the answer, yes, I remember. It's tan inverse 1, that's pi by 4, pi by 4 multiplied by, the denominator is 2, so it will be pi by 8 here. Minus 1, that's half. Again, plus pi by 4 and it's pi by 8. Pi by 8. Why? Because this one over here, right? Plus half into pi by 4. 4 and 2 in the denominator, when you multiply, it'll be pi by 8 minus 0. So now you can just simplify this. This minus half remains. You can use your calculator, but pi by 8 and pi by 8, how do you solve it? Pi by 8 plus pi by 8. There are 2 pi by 8s. 2 pi by 8 will be 1 and 4. So whenever you have the same terms, it'll just be half of that in the denominator. It's pi by 4. So it'll be pi by 4 minus 1 by 2. So that must be the final answer. The answer is pi divided by 4. Pi by 4 minus half. Now this is in radians. So here, otherwise it'll be 45 degrees minus half. That wouldn't make sense. So write it in radians. You can see that will be the answer. That is the end of this question. I hope it is clear. If you have any doubts, please consider rewatching the video or posting your doubts in the comments. I hope you all will head on to the next video.